Good day and welcome to One-on-One Maths Private Tutors. We continue with graphs of functions. We are still solving quadratic equations using graphical methods. Sometimes you may have drawn a quadratic graph and then need to solve an equation that is different from the graph you have drawn. Rather than drawing another graph, it may be possible to rearrange the equation to obtain the one you have drawn. Let's look at this example. We are asked to draw the graph of y is equal to x squared minus x minus 3 for values of x between minus 3 and 4. And we will use this graph to solve this equation, which we can see is different from that equation, but the left-hand side is the same. And this equation, which is different from that equation, but we can rearrange the terms here so that we have something like this right-hand side here. First, let's draw the graph. We want values from minus 3 to 4, so we need a table of values. So we have our table of values, x and y. For x, we have minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. So again, we go through the working. Our equation is y is equal to 2x squared minus x minus 3. So we substitute x values in turn to get the corresponding y value. So we say when x is equal to minus 3, y is equal to 2 times minus 3 squared minus 3 minus 3, which will give us minus 3 squared is 9 times 2 it's 18 plus minus times minus is plus 3 minus 3, which will be 18. So we have 18 there. And say when x is equal to minus 2, y is equal to 2 times minus 2 squared minus 2 minus 3, which will give us minus 2 squared is 4 times 2 it's 8 plus 2 minus 3, which is 10 minus 3, which is 7. Here we have 7. And we go to minus 1. When x is equal to minus 1, y is equal to 2 times minus 1 squared minus 1 minus 3, which is 2 plus 1 minus 3, which is 0. So this is 0. When x is equal to 0, y is equal to 2 times 0 squared minus 0 minus 3. Oh, this is 0. This is equal to minus 3. So go to our table of values, minus 3. Now we go to 1 and say when x is equal to 1, y is equal to 2 times 1 squared minus 1 minus 3, which is equal to 2 minus 1 minus 3, which is 2 minus 4, which is minus 2. So there we have minus 2. When x is 2, y is equal to 2 times 2 squared minus 2 minus 3, which is 2 times 4, which is 8, minus 2 minus 3, which is 8 minus 5, which is 3. So here we have 3. Now when x is equal to 3, y is equal to 2 times 3 squared minus 3 minus 3, which is equal to 3 squared is 9. 9 times 2 is 18. Minus 3 minus 3 is minus 6. So we have minus 12. So we have 18 minus 6, which is 12. Here we have 12. When x is 4, y is equal to 2 times 4 squared minus 4 minus 4, which is equal to 4 squared is 16 times 2 is 32 minus 4 is minus 8, which is 24. Here we have 24. So our table of values is complete. Our values of x are starting from minus 3 to 24. So we need our x-axis down there, minus 3 to 4. So we can have minus 3 here, minus 2, minus 1, 0 there, 1, 2, 3, 4. Our y values, minus 3 to 24. One axis there, minus 5 there. Two small squares to represent 1 unit. Then we can have 5, 10, 15, 20, 25, 30. That is a good scale that will not confuse us. So now we use our table of values. Let's label our axis. This is our y and this is our x. Let's put in our points. When x is minus 3, y is 18. So we go to minus 3, 18. If this is 15, 16, 17, 18. So we go, it means with minus 3. When x is minus 2, y is 7. So minus 2, y is 5, 6, 7. So this is the point where the two meet. Minus 2, 7. When x is minus 1, y is 0. Minus 1, 0. When x is 0, y is minus 3. X 0, y minus 3 minus 1 minus 2 minus 3 there. When x is 1, y is minus 2. So this is the point 1 minus 1 minus 2. When x is 2, y is equal to 3. x2, y equal to 1, 2, 3. 2, 3. Okay? When x is equal to 3, y is 12. X is 3, y is 10, 11, 12. Here. When x is equal to 4, y is 24. 21, 2, 3, 4. Remember, two of these small squares are representing 1 unit. So from 25, it's only 2 blocks, 2 small squares down. What we need to do is to connect these points in a smooth curve. Now we can answer questions B1 and B2. 2x squared minus x minus 3, which is the graph we have, is equal to 6. So we need the graph. We have y is equal to 2x squared minus x minus 3. We need the graph of y is equal to 6. So this is a horizontal line passing through y is equal to 6. Y is equal to 6 is here. So we need a horizontal line. So this is our y is equal to 6. And this is our y is equal to 2x squared minus x minus 3. So we are interested in these points of intersection. So we'll take vertical lines from where the two graphs meet. We want this value there and this value there. This is minus 1.9 and this is 2.3. So now we can say x is equal to minus 1.9 or x is equal to 2.3. Okay, so those are our solutions. Now for B, we have 2x squared minus x is equal to x plus 5. So we want to manipulate this equation make sure it still remains the same, but it has one side with this expression, 2x squared minus x minus 3. So if we have 2x squared minus x is equal to x plus 5, we can say 5 is the same as 2 plus 3. So we can say 2x squared minus x is equal to x plus 2 plus 3. So this 3, when it comes to that side, it becomes negative. So we have 2x squared minus x minus 3 is equal to x plus 2. This is still the same equation as that. But now we have manipulated it so that this left-hand side has this. Now we have the graph of y is equal to this 2x squared minus x minus 3. We want the graph of y is equal to x plus 2. So this is a linear graph. We just need 2 points. We can use the x and y intercept or any 2x points and find the corresponding y and then draw it. So what I will do is I will just say when x is equal to 0, y is equal to 0 plus 2, which is 2. Y-intercept. Now I can say when y is equal to 0, that is on the x-axis, we are looking for the x-intercept. 0 is equal to x plus 2. Then we take this plus 2 to the other side, it becomes negative. So we say x is equal to minus 2. This is the x-intercept. So now we can say this is the x-intercept minus 2 and 2 on y. Join the 2 points. This is the graph of y is equal to x plus 2. So we want to see where x plus 2 is equal to 2x squared minus x minus 3. So it's this curve, our quadratic curve, and our line. So we want the x values. So we go to the points of intersection. So these are the points we are looking at. So this is 2.1 and minus 1.1. Now we can say x is equal to 2.1 or x is equal to minus 1.1. So that's how we use and manipulate quadratic graphs to solve equations using the graphical method. Thank you.